This video is going to show you how to do pH and pOH calculations and how to change back and forth from hydrogen ion to hydroxide ion. A good place for you to start is at my home page, which is mrwiggerside.com/chem, and you can see that address right up here. And going as a site search, now this is a Google search just for my site, you will be able to put in pH chart. And when you put in pH chart, the first hit you're going to get on this is a log chart for the numbers 1 through 10. When you go there, this is what it will look like. And we will be using this throughout the video. After I introduce these basic formulas, and this first one here actually comes from the K sub equilibrium, or the K sub EQ, which you see on the far left there. And let's get this up here there we go. Now you can just see the one thing. This K sub EQ here is actually the K sub W, or the equilibrium constant for the ionization of water. And when water ionizes, it forms hydrogen ions and hydroxide ions. And as such, when we get these concentrations of each and multiply them by each other, it comes out to a constant value of 10 to the minus 14. You probably want to write it down like this, though. And so copy that down and copy down this guy right here. So right there you have the pH and pOH relationships. Up here you have the hydrogen ion and hydroxide ion relationships. It's also important to know that these things all come from minus log of a hydrogen ion concentration is equal to the pH. And I'll explain how that works in just a moment. And you can see a shadow down here of the same thing for hydroxide ion concentration and how to get it to the pOH. And now we're going to go to some examples. And we got that same thing there. We're going to be looking at this chart. This chart actually comes from your textbook and page 611. And this chart is just a marvelous little chart to get you oriented. So let's move it across, and you can see that it covers the whole range of pH, or most of it anyway. pH can actually go, and pH is of course the top numbers. Okay, these are our pHs, and this goes all the way up to sometimes 15 or 16 with outrageously strong bases, and all the way down to as low as, sometimes I understand we can get down as low as -4 on the pH, which is just outrageously strong for an acid, and that would be very highly concentrated. And so we'd be looking at concentrations of hydrogen ion that go, just into the 10 squared and 10 cubed area, which is just, I don't know how they do that. But I have heard that there's exotic acids that will do that. But at any rate, this is the one we deal with most often in our chemistry. So down here, you're seeing pOHs and their concentrations at each pOH, the hydroxide ion concentrations. So increasing activity, or increasing acidity right here, going to the left, and as you roll this guy over, increasing base, or neutral in the middle, and base going this way, and acid going this way. So now that you're oriented to this, let's take a closer look at a few things. Okay, as we look at pH, we start at the far left with a 0, and that's where the concentration is 1. That 1, by the way, is actually 10 to the 0, okay? And that goes all the way up on this scale to 10 to the minus 14. So this guy is very easy to figure out with going back and forth from these numbers to these numbers. If you look at it, all you're doing is changing the sign on the exponent of 10, and then you bring it down as a whole number, and that becomes the pH. And by the way, that is how we take the log, or the minus log, of the pOH, or the minus log of the pH. And so I've just turned that upside down, and now see the pOH down here? It's the minus log of the hydroxide ion concentration, where the pH is the minus log of the hydrogen ion concentration. And that's how we go back and forth. So now we go into look at the hydroxide side. Hydroxide side, got that? Anyway, the hydroxide ion concentration is given here, and that goes and starts at minus 14 and goes all the way down to 10 to the minus 1, right there for the concentration. And you'll notice that the pOH is 1, where to get the pH, we're actually way on the other side here, and pH now goes all the way to 1 here on the opposite end. And again, we're looking at acid on the left and base on the right. And the further we get from the center, the stronger the solutions are for hydrogen or hydroxide. And this little guy belongs right here. So this 10 to the minus 0 is actually 1. Okay, that's just mathematics. Now, let's go and look at some other. So I will show you in a second video how to do the pH and pOH conversions that we did on the worksheet, which you're looking at right now, both the front and the back. So that's coming on the next video, and hope you watch that one too.